So in this class, we shall be discussing about some reactions of metal carbonyl complexes. Okay, so we will be discussing some important types of reaction of metal carbonyl complexes. Now, among the first one, this is the oxidative addition reaction. Oxidative addition reaction. Now, in this oxidative addition reaction, it means oxidation of metal center, oxidation of metal center. So this will involve oxidation of metal center and addition of substituents, addition of say a reactant, addition of reactant. Okay. So among the most important oxidative addition reactions, this is a very famous reaction. If we start with IR, CO, Cl, PPH3 whole twice. So you can well understand that iridium is in +1 oxidation state and it is a D8 system. So since it is a D8 system, so and tetra coordinated, it will be square planar, because D8 system, if the Delo value is high, it is square planar. Why the Delo value is high? Because iridium is 5D element. Okay, so this is a square planar complex and this is known as viscous complex. Okay, this is viscous complex and this is the one of the very first examples of synthetic oxygen carrier. Synthetic oxygen carrier. So we know that hemoglobin, it is a biological oxygen carrier, isn't it? So it carries oxygen from lungs to different parts of the body. So how can it carry oxygen? By binding. You'll find later on we'll be teaching that this oxygen gets bonded to the iron center in hemoglobin. So in a similar way, this molecular oxygen gets bonded to the iridium center of viscous complex. Okay, and the reaction occurs via the, this is a type of oxidative addition reaction. Now if you look closely to this reaction, see the square planar iridium 1 complex IR CO Cl PPH3 whole twice. I'm just writing P instead of PPH3. It is a square planar complex and the two phosphine groups, they will occupy positions trans with respect to each other in order to minimize steric repulsion. Now when this is treated with oxygen, okay, when this is heated with oxygen in non-polar solvent, what happens? If you look at the molecular orbital picture of oxygen, this is the HOMO, this is pi star HOMO, this is for molecular oxygen, and you know that spin multiplicity, this is S koto 1, spin multiplicity is 3 in the triplet state. This is the stable form. What happens? This iridium center, it transfers a pair of electron to oxygen. Now when it transfers a pair of electrons to oxygen, what happens? This oxygen is converted to peroxide. How it is converted to peroxide? See, these are the two electrons of molecular oxygen, and these two electrons, they are accepted from the iridium center. So this is converted to peroxide. So this molecular oxygen is converted to peroxide and this peroxide gets linked to the iridium center. That means what happens is that the peroxide moiety, look, this is the peroxide moiety, when the oxygen is coming closer, see the two triphenyl phosphines, they will occupy trans positions, and when the oxygen molecule comes closer, this behaving as peroxide, it will form a three-membered chelate. Okay, and this is converted to iridium 3. So metal center is oxidized, and this entire reagent is added in the form of peroxide. ওকে, সো তার মানে এই peroxide এটা দেখো, this is 2 minus and this is 1 minus, so the charge of the metal center is balanced. So this type of complex is formed, and that is why we say that this viscous complex behaves as the synthetic oxygen carrier. And look, this is a case of oxidative addition. Oxidation of the metal center along with addition of this molecular oxygen in the form of peroxide. Okay, so this is a very important example of oxidative addition reaction. Now, suppose if you consider another reaction, say Mn Mn2CO5 Mn2CO5 na Mn2CO10. So this is Mn2CO10. As if you look at this metal-metal bond, as we have explained in the previous class, this bond is weak, isn't it? We have explained this in terms of JT effect, Yan-Teller effect. This bond is weaker. Now what happens when this is treated with molecular hydrogen? See, initially this metal center, it is in the zero valence state. And how will it react with molecular hydrogen? Now, if you look at this MnCO10, Mn2CO10 rather, this hydrogen molecule, we know that this is sigma and sigma star. This is the pair of electron in sigma, and sigma star is vacant for hydrogen. So what actually happens is, see, since the Mn bond is weak, this bond is readily cleaved, okay, in presence of molecular hydrogen, and these two electrons they are transferred to this sigma star orbital. So when this is transferred to sigma star orbital, so what's going to happen? See, this bond will break because the bond order becomes 0, and in presence of 2 electrons it is converted to 2 twice hydride ion in presence of 2 electrons, isn't it? The bond order becomes 0, and since there are 2 extra electrons, it will be converted to 2 hydride ions, and this hydride ion gets linked to each of the manganese center. That means this hydride ion will be linked to each of the manganese center. So if this is -1, then the oxidation state is +1. Okay, so this is some sort of an oxidative coordination, not really oxidative addition, because if it is oxidative addition, then the entire reagent should be added. In oxidative addition reaction, the entire reagent should be added. Okay, so we can say this is some sort of a oxidative coordination reaction. That means when we are starting with Mn2CO10 upon treatment with hydrogen, this is converted to this is converted to HMnCO5, HMnCO5. So this occurs via transfer of electron from manganese center gets oxidized. So this is some sort of a coordination oxidative coordination হচ্ছে. Now there is another type of reaction known as oxidative decarbonylation reaction. Achha, if you look at this reaction, oxidative, so the second category of reaction. So initially oxidative addition, then oxidative decarbonylation. See, in oxidative decarbonylation, if you look at FeCO5, okay, FeCO5, and when this is treated with iodine, so initially it is in the zero valence state, and for iodine, once again, this is sigma, and sigma star is the LUMO. Okay, sigma star is the LUMO. Let us consider only sigma star here. Sigma star is the LUMO. So what happens? This iron center donates a pair of electron to iodine. It accepts this in the sigma star LUMO. Now once it accepts in sigma star LUMO, this iodine is converted to, in presence of 2 electron, it is converted to twice I minus. Iodine bond ভেঙে যাচ্ছে, bond order becomes 0, and দুটো I minus যেটা হচ্ছে, so the final product is FeCO4 I2 plus CO. So it is oxidative decarbonylation, মানে একটা কার্বন মনোক্সাইড বেরিয়ে যাচ্ছে. So oxidation হচ্ছে, oxidation along with removal of carbon monoxide. So this is oxidative decarbonylation, carbon monoxide বেরিয়ে যাচ্ছে. So this is an example of oxidative decarbonylation reaction. Okay, fine. Now let us consider another reaction, another type of reaction, that is the third category, that is insertion reaction. Insertion reaction. So this is the third category of reaction, that is insertion reaction. Okay, so this reaction is also very, very important. Now, first of all, we will discuss, there are two types. First of all, we will discuss migratory insertion reaction. Migratory insertion. Okay, migratory insertion. Migratory insertion means, suppose if you look at this metal carbonyl complex, I am explaining it in a general way, and suppose there is X is linked to the metal center. Now what happens during migratory insertion reaction? This X comes here, and এইটা গিয়ে কি হচ্ছে, MCX double bond. Now please try to understand, this is not organic chemistry, and এই যে electron pair যেটা দিচ্ছে, since octet rule is not applicable for organic complexes, don't try to think in terms of octet rule, because organic chemistry তুমি octet rule দিয়ে সবকিছু এক্সপ্লেন করতে পারো, কিন্তু এখানে হয় না. তাহলে আসলে জিনিসটা এই রকম একটা কমপ্লেক্স তৈরি হচ্ছে, As if you look closely, initially there was metal ligand. Initially there was metal ligand bond. This ligand X. Initially there is a bond here, isn't it? And now you see this carbon monoxide, this CO group. This CO group is inserted between the MX bond, as if the CO group is inserted, ঢুকে গেছে within the MX bond. এবং কিভাবে হয়েছে? বাই মাইগ্রেশন অফ এক্স। এই যে মাইগ্রেশন হয়েছে, এক্সটা এখান থেকে এখানে মাইগ্রেট করেছে। সো বাই মাইগ্রেশন অফ এক্স, what happens? The CO group is practically inserted between M and X. So that is why it is an example of migratory insertion. Now if you look more closely, this is initially this X is one bond away from the metal center, and now it is linked to an atom. Now it is linked to an atom which is also one bond away from the metal center. Initially X was one bond from the metal center, and now it is linked to an atom which is one bond away from the metal center. So যে কারণে one migratory insertion, one migratory insertion reaction. So this is a case of one migratory insertion reaction. I mean, initially X was one atom away from one bond away from the metal, and now X is linked to an atom which is one bond away from the metal. So this is a case of one migratory insertion. Now if you look closely, if you consider a real example, suppose a Mn তোমাকে বলা হলো MnCO5 CH3, ঠিক আছে, upon treatment with isotopically labeled carbon monoxide. তোমাকে কিরকম কোয়েশ্চেন দেয়, দিয়ে তোমাকে বলা হলো যে প্রোডাক্টটা কি হবে, এ বি সি ডি করে চারটে তোমাকে দিয়ে দিল যে হোয়াট শুড বি দ্য প্রোডাক্ট। তোমাকে বুঝতে হবে এখানে যে in this case there will be migratory insertion reaction. How? You will look at, suppose this is the methyl group and these are the carbonyls. These are the carbonyls. Now when this is treated with isotopically labeled carbon monoxide, what happens? This methyl group migrates to a neighboring cis carbonyl. দেখো neighboring cis positions যেগুলো, cis positions গুলো কোনগুলো? All these are cis positions with respect to methyl. All these are cis positions. So it will migrate to any of these cis positions, and this carbon monoxide will occupy this position, the vacant position. So what happens? This MnCO CH3 এইখানে isotopically labeled carbon monoxide. So isotopically labeled carbon monoxide is linked to the metal center. So এই ধরনের রিঅ্যাকশন হচ্ছে, দেখো মাইগ্রেটরি ইনসারশন হচ্ছে। Now in a similar way, if this is treated with triphenylphosphine, so instead of carbon মানে isotopically labeled carbon monoxide যেটা এখানে লেগেছে, তো সেখানে ফসফিন লেগে যাবে। Similar reaction will take place. There will be migratory insertion, and দেখো এই যে migratory insertion, এটা one bond away ছিল, now it is also one bond away, মানে it is also linked to an atom. কোন অ্যাটমটা? এইটা, which is one bond away from the metal center. So it's a one migratory insertion. তাই তো? তাহলে দেখো in this one migratory insertion, the PPH3 লেগে যাবে. So these are some good examples of one migratory insertion reaction. ঠিক আছে, তাই এই রিয়াকশনটা কিন্তু ইম্পর্টেন্ট। নাও see the insertion reaction may or may not be migratory. এখন আমরা দেখালাম না এখানে, আমরা কি বললাম দেখো, we have mentioned that it's a migratory insertion. Now it may not be migratory, so it can be, it can be non-migratory insertion also. How? So non-migratory insertion, non-migratory insertion. Say suppose if we start with HCrCO5, দেখো HCrCO5 এটা তো হাইড্রাইড, তার মানে ক্রোমিয়াম 1 হচ্ছে, তাই তো HCrCO5 ক্রোমিয়াম 1 মিন্স ক্রোমিয়াম কত 24, ক্রোমিয়াম 1 মানে হচ্ছে 23, 18 আর 5 D5 low spin system, and obviously it is octahedral, D5 low spin octahedral. So what will be the product if this is treated with if this is treated with CX2? Now X can be oxygen or sulfur. So let us consider two different cases. Let it be carbon dioxide when this is treated with carbon dioxide, and when this is treated with sulfur dioxide. So what should be the product? What should be the product? So you have to understand that this is a case where there will be এরম যদি reaction হয়, you have to remember যে দেখো এইটা হচ্ছে নন মাইগ্রেটরি ইনসারশন হচ্ছে। কিরকম নন মাইগ্রেটরি ইনসারশন? অ্যাকচুয়ালি এই যে ধরো আমরা যদি প্রথমে কার্বন ডাইঅক্সাইড দেখাই CO2, এই কার্বন ডাইঅক্সাইড, you know it is a linear molecule. So what happens, এই কার্বন মনোক্সাইড, এই হাইড্রাইড যেটা, এই হাইড্রাইডটা will মানে this carbon dioxide rather will be inserted um, between chromium and hydrogen. মানে আমরা বলতে চাইছি যে দেখো this is এই ক্রোমিয়াম আর হাইড্রোজেনের মধ্যে this CO2 will be inserted. কিভাবে ইনসার্টেড হচ্ছে? দেখো এই Cr, এই কার্বন মনোক্সাইড গুলো যেরকম ছিল, এইখানে যেটা হচ্ছে this C ডাবল বন্ড, C না এটা X দিয়ে লাগবে, সরি এটা O দিয়ে লাগবে, O C, এখানে ডাবল বন্ড O H, বুঝতে পারছো? So in this case it's a non-migratory insertion হচ্ছে, এবং এখানে আমরা দেখতে পাচ্ছি কি হচ্ছে জিনিসটা, এইখানটায় এইটা এখানে যাচ্ছে আর হাইড্রাইডটা বেরিয়ে এখানে লাগছে। So it's a case of non-migratory insertion. In a similar way, if you react this with sulfur dioxide, দেখো সালফার ডাইঅক্সাইড তো জানো ইট ইজ প্ল্যানার ট্রাইগোনাল, একই ব্যাপার। আচ্ছা এখানে চার্জটা যদি দেখো, এখানে চার্জটা এটা তো মাইনাস হয়ে যাচ্ছে, তার মানে এখানে আমরা চার্জ যদি দেখি এখানে দেয়ার উইল বি, এটা ও দিয়ে হচ্ছে CHCOO মাইনাস, এটা একটা ঠিকই আছে। সো দিস ইজ Cr, এই CO 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 CO, আর এখানে কি হচ্ছে, এখানে একই ব্যাপার ও এস double bond O H, like this. So this is a non-migratory insertion because hydride is not migrating towards these carbonyls. এই যে চারটে সিস কার্বনিলস আছে এখানে হাইড্রাইড মাইগ্রেট করছে না, বুঝতে পেরেছো তো? হাইড্রাইড কিন্তু এখানে রয়ে গেছে। এবং in this non-migratory insertion আমরা দেখতে পাচ্ছি initially hydride is one bond away from the metal. Now it is linked to an atom which is two bond away from the metal. So initially the hydride was one bond away from the metal, and now this hydride is linked to an atom which is two bond away from the metal. So in this non-migratory insertion we can say it is a 1-2 non-migratory insertion. 1-2 non-migratory insertion. ঠিক আছে? বেশ। Next, let us come to another example. This is known as Haber-base reaction. In this Haber-base reaction কি হচ্ছে, এই টাংস্টেন হেক্সাকার্বনিল, ঠিক আছে, টাংস্টেন হেক্সাকার্বনিল. Now when this is treated with methyl iodide in ether, ঠিক আছে, methyl iodide CH3I in anhydrous ether. ether বলতে এখানে anhydrous ether নিচ্ছ. So in the first step this is converted to W. It's octahedral complex. দেখো এইখানে কি হচ্ছে, so in the first step this is converted to a CH3 এখানে লাগছে O minus Li plus, and upon further treatment with this trimethyl oxonium BF4 minus, this is converted to এই জিনিসটা, this is converted to CH3 OCH3. So lithium is substituted. So this is how, you see a carbene is formed, C double bond W হচ্ছে. So this is known as Fischer's carbene. তাহলে Fischer's carbene কাকে বলে? You should know this. What is Fischer's carbene? Isn't it? So this is Fischer's carbene. So this is what we say is Haber-base reaction. Next, we need to know what is Coleman's reagent. See, Coleman's reagent. Coleman is a very famous scientist. Coleman's reagent. Coleman's reagent হচ্ছে Na2FeCO4. এটাকে বলা হয় Coleman's reagent. ঠিক আছে? Now, এই যে অ্যানায়নটা, এইগুলোকে আমরা কি বলি? কার্বোনাইলেট অ্যানায়ন. দেখো এই যে FeCO4 2- এটাকে আমরা কি বলবো? কার্বোনাইলেট অ্যানায়ন. কার্বোনাইলেট অ্যানায়ন. দেখো এই যে Coleman's reagent, this can be synthesized starting from FeCO5. See, when you treat FeCO5 with metallic sodium দিয়ে যখন ট্রিট করছো তখন কি হচ্ছে, in obviously liquid ammonia, sodium in liquid ammonia. So this is converted to Na2FeCO4. That means this FeCO4 2-. This is actually we are interested with this product only. তাহলে এই জিনিসটা তৈরি হচ্ছে, this is the Coleman's reagent. Now this Coleman's reagent, it can be utilized to synthesize a wide range of organic compounds. কিরকম? দেখো this Fe CO4 2 minus, FeCO4 2 minus. So what is the oxidation state of iron? Obviously -2, কারণ সোডিয়াম, দুটো সোডিয়াম দেখো দুটো ইলেকট্রন দিয়ে দিয়েছে এখানে, নিয়ে এটা -2 হয়ে গেছে, তাই তো? তাহলে at this lower oxidation state, now when this is treated with CH3COCl, so what happens? See, this is in -2 oxidation state, so this will behave as a nucleophile, chloride বেরিয়ে যাবে, so the product will be what? FeCO4, আর এদিকে দেখো COCH3 হবে। এখানে আমরা এইভাবে দেখাচ্ছি, পেন্টা কোঅর্ডিনেটেড, obviously COCH3, আমরা এখানটাকে this is COCH3 মাইনাস হচ্ছে, কারণ 2 মাইনাস থেকে এটা মাইনাস হচ্ছে, একটা ক্লোরাইড এখান থেকে বেরিয়ে এটা মাইনাস হচ্ছে 2 মাইনাস থেকে, ঠিক আছে? নাও if you treat this with oxygen, so this is the TBP complex which can be utilized, তার মানে এই জিনিসটা দেখো, this is actually activated, this moiety is activated, and if you treat this with molecular oxygen, this is converted to CH3COOH, তাহলে এটা activated moiety. Now when this is treated with RX, alkyl halide, so CH3CO R ketone হচ্ছে, this is acidified, upon acidification this is converted to CH3COH, aldehyde হচ্ছে, and upon treatment with halogens this will be converted to CH3COX. So Coleman's reagent is very important, particularly you'll find that they can give you MSQ question, which of the following is correct with respect to Coleman's reagent. দেখো Coleman's reagent নিয়ে আমরা অনেক কিছু বললাম, ঠিক আছে? এটা দিয়ে অনেকগুলো সিনথেসিস হচ্ছে, we can synthesize a large number of complexes. Okay, now let us consider another reaction in metal carbonyls, that is reductive elimination. Okay, reductive elimination reaction, যেমন oxidative addition বললাম, next we shall discuss about reductive elimination. দেখো reductive elimination মানে এখানে, reductive elimination means reduction of the metal center, reduction of the metal center along with removal of some substituents, See, suppose if I look at this complex RH CH3 COH PPH3 whole thrice P53, এখানেও ধরো একটা PH3 whole thrice and Cl. Now in this complex আমরা বুঝতে পারছি, দেখো এই যে কমপ্লেক্সটা, এটা রোডিয়ামের অক্সিডেশন স্টেট কত, দেখো এটা -1, এটা -1, এটা -1, তাহলে রোডিয়ামের অক্সিডেশন স্টেট ইজ +3, তাই তো? এখন এই যে কম্পাউন্ডটা, now this compound, if you look closely, this is not very stable. Why? Because there are two phosphine groups which are close to each other. So there will be some amount of steric repulsion. Okay, and to avoid this steric repulsion, what happens? See what happens? This methyl and this hydrogen. Okay, it is lost. কিভাবে? দেখো এই মিথাইলের এই তো পেয়ার অফ ইলেকট্রন আছে, ঠিক আছে? এই মিথাইল ডট বেরোচ্ছে, ইলেকট্রন একটা রোডিয়াম নিচ্ছে, আবার এখান থেকে এইচ ডট বেরোচ্ছে, এখান থেকে একটা ইলেকট্রন নিচ্ছে। তাহলে মিথাইল ডট আর এইচ ডট মিলিয়ে এই যে এইচ ডটটা বেরোচ্ছে আর মিথাইল ডট, এরা মিলিয়ে ইট উইল বি কনভার্টেড টু মিথেন CH4, and this is converted to the square planar sterically more favorable complex. Sterically more favorable complex, and you see this is rhodium 1 because it is accepting a pair of electrons. So this is reduction of metal center reduced হচ্ছে, removal of some of the substituents in the form of H and CH3 is lost. So this is reductive elimination, isn't it? So we have discussed about oxidative addition and reductive elimination. দেখো দুটো just opposite. Oxidative addition আর reductive elimination তুমি যদি দেখো, these two they are just the reverse, isn't it? তাহলে আমি oxidative addition এর জন্য আমার কি হতে হবে? What are the criteria? একটা oxidative addition reaction আর reductive elimination reaction এর জন্য কি ক্রাইটেরিয়া দেবো বলো? তাহলে আমরা বলতে পারি ক্রাইটেরিয়া ফর অক্সিডেটিভ অ্যাডিশন রিঅ্যাকশন। একটা হচ্ছে মেটাল সেন্টার should be in lower oxidation state and should exhibit variable valency, তাই তো? একটা হচ্ছে লোয়ার অক্সিডেশন স্টেটে হবে and should exhibit variable valence. 2 number point, metal center should be coordinatively unsaturated, তার মানে it should be able to increase its coordination number. It should be able to increase its coordination number, coordinatively unsaturated হতে হবে। আর criteria for reductive elimination, একটা হচ্ছে মেটাল সেন্টার যেটা হচ্ছে should be in higher oxidation state and should exhibit variable valence. 3 নম্বর, metal center 2 নম্বর কি, metal center should be coordinatively saturated হলে তবেই তো সেখান থেকে বেরোবে। So these are some of the criteria of oxidative addition and reductive elimination. So we shall continue with this in the next class.